Okay, I see there are few people there. To those, I would like to say hello. How is everyone doing? I hope everyone is doing good. And yeah, this session is going to be just a briefing about what digital forensics is. Okay. So before we move any ahead, am I audible to everyone? Am I audible to everyone? I would. Am I audible to everyone? I would like to get a yes or a no. Am I audible to everyone? I hope I am audible to everyone. Okay. So yeah, to those who are present currently, I'd like to tell them a hi. Hello. How are you guys doing? Okay. So again, just for a confirmation, I want to know, am I audible? Am I properly audible or not? Okay. So I'd like to give myself a brief introduction about me. My name is Eganga Shankar, and I am here representing the digital forensics team of Team BIOS. And for those who don't know what I'll be talking about today, I'll be mainly talking about two of the major file structures that come across quite a lot of the CTFs and quite frequently also. They are namely PNG and JPEG file structures. So, before we go into their file structures, I would like to talk about the importance of file structures. So I know for a fact quite a lot of people here might have used the tool called binwalk and all. So what really file structures is that it defines how all your corresponding data, at the end of the day, everything comes down to data, starting from your images and all. They all comprise of data. The different ways of storing them is what I would call as file structures. You can store different files in different ways, and those are all your file structures. You have different ways to represent different files, and these all files could be having different file structures. Now, talking about PNGs, right? So PNG file for an okay. So how many of you here know about PNGs? Even if quite a lot of you guys don't know, I'll briefly explain about it now. So a PNG basically PNG, it's an abbreviation for the word portable network graphics. So many of us, we might have downloaded a PNG with or without knowing in our life. And yeah, most and PNGs usually store high quality images rather than unlike JPEGs and all. Now, talking about JPEG file structures, JPEG file structures are generally not preferred these days because of the how less in quality they can be at times. how less of a quality they can be at times. Now at the end of the day, these are both formats in which you can define your images. Now these are not the only ways of defining an image. You also have GIF, which is like multiple frames of images in one, and you can also have other file formats such as BMP and all. Now what I'm going to talk about first is PNG file structure. Now, when you talk of PNG file structure, I'll be covering the following contents today. So, the session plan that is overlaid over here, we are basically going to discuss about what a PNG actually is, what PNG headers are, and what chunks are, what CRC is, and and the entire PNG file structure. And also, I'll be displaying or showing you guys a few methods by which you can corrupt images. Now, what is a PNG? As I mentioned earlier, PNG stands for Portable Network Graphics. It's an image format that supports lossless data compression. What this means is whenever you are sending an image through it being in the PNG format, it will always make sure that all your pixels are all intact and thus none of the data is lost. It is widely used in the current market, and also a lot of the images that you get and you see in websites are mainly all PNGs. Now, when you talk of when you talk of PNG, we first need to know the PNG structure, right? So, I'm going to be briefing everyone about what PNG structure really is. And the first thing that comes to our mind is PNG header. So, not just PNG header, every file that you come across usually has a header, every file structure. Let it be JPG, let it be PNG, let it be GIF. All of these files, they tend to have a header. Now, what is a header? So, a header is basically nothing but it's the uh, those are those bytes which are used to identify a file format. By that I mean whether your system doesn't know whether the image is a PNG or whether the image is a JPEG or not. In order for your system to identify whether the given file or image is a PNG or a JPEG, it needs to have some reference. And these reference values can be taken from PNG headers. Okay, not PNG, any file headers. Now, as you can see, the PNG header is mainly comprised of 8 bytes, and this will remain universal across all PNGs. This doesn't change. The first 8 bytes of a PNG will always be the following bytes that I mentioned here. They are 89, 50, 4E, 47, 0D, 0A, 1A, 0A. Now, let's talk about chunks. So, what are chunks? So, it's like imagine a block. You need to store data at the end of the day. So, you have to make sure that this data is stored in such a way that it is easy for you to manage. It is easy for your device to manage, and it is easy, and it makes management and manipulation easier. So, this role is mainly done by chunks. What chunks do is they technically store all your relevant stuff or all your relevant data that is needed, and they use it to make the file management better. Now, uh, as you can see here, fundamental blocks of a file is called a chunk. It makes data manipulation and management easier. Now, the relevance of chunks could go from one extent to other. If your file structure is not properly aligned, it becomes hard for your system to detect what kind of what kind of data the file is holding, and what's the use of the data bytes. Now, when we now there comes an interesting thing called CRC. CRC stands for cycle redundancy check. For those who don't know what CRC is like an error checking mechanism. Suppose you have a certain set of bytes, and you have to check whether the data represented inside that chunk is correct or not. Now, your chunk basically comprises of uh, the general structure of a chunk is as follows. So when you have a chunk, the 4 bytes before the chunk name will be the chunk length. And after the chunk name, there will be corresponding bytes which correspond to the chunk length. Now, after that, there will be something called as the CRC values. Now, talking about that was just the chunk structure, the general chunk structure. Now, what really CRC does is it checks whether the data inside your chunk is valid or not. That is what CRC does. And for those who have used the tool called PNG check, they can infer and understand that by using the tool. Now, as you guys can see, this is the PNG file structure. This is how it looks usually. So you have the first 8 bytes, 89, 50, 4E, 47, 0D, 0A, 1A, and 0A. Now, after that, you have the length of the chunk. Then after that, you have the chunk name. Then after that, you have the data. And now if you look at here carefully, so 0000000D, it corresponds to 13 in decimals. So after the chunk name, if you look at it carefully, there are 13 bytes that correspond to there are 13 bytes that correspond to the IHDR chunk name. And then after that, you can see there are 4 bytes which represent the CRC value. Now, you can see that the CRC value, right? The CRC value is often computed keeping in mind the data that is present inside the chunk. Now, whatever data that you have here specifically, I'm talking about the IHDR chunk. You have the IHDR chunk over here, the 13 bytes over here, some mathematical formulations will be applied on those, and you'll get the CRC values. The CRC values are always 4 bytes long. Now, I'll open a PNG and show you guys how it usually looks like. Okay, so before I talk about the PNG hex structure, I'd like to make sure that this tool that I'm using currently, it's called 010 Editor. It is, I would say, one of the better hex editors out there, and you can easily, I would say, it is way more convenient than using other hex editors such as XXD and ghex. It makes file handling way more easier, and you can easily go through each part. And in fact, you can make sure that you can easily make sure that you can manipulate the bytes given in the file structure. Now, here I've opened a board.png. Now you can see that as I said, the PNG is often identified by its first 8 bytes. You have the first 8 bytes of magic number, then the next the role of magic number ends there. You don't have to confuse yourself with the magic header and the chunk. The magic header is not a chunk. Now, it's just 8 bytes that represent a file structure. Now, what you have over here, you can see is IHDR. Every PNG has mainly two chunks, two types of chunk. They are ancillary chunks and critical chunks. Now, when you think of critical chunks, these are the chunks that are needed by the PNG to exist. Now, under those, we have uh, chunk names like IHDR, we have IDAT, we have IEND. Now, for your information, uh, a PNG can have multiple IDATs. A PNG can have multiple IDATs. A PNG will only have single IHDR chunk. I'll sh- A PNG can have multiple IDAT chunks. It will only have a single IHDR, and it will always end with an IN. Okay. Now, I hope none of you have doubts still here, because I'll be explaining this structure in a bit more expanded way. If you guys have any doubts, you can put it in the chat if you want. Anyone there with doubt? Okay, I'll continue with my session. So, as I was mentioning, you have the chunk. So here I'm talking about IHDR chunk. So after IHDR, before the IHDR chunk name, you have 4 bytes which represent the chunk length. So here you have 0 0 0 0 0 0 0 D. 0D basically becomes 13 in decimal. So you can say after IHDR, there are 13 chunks which correspond to the IHDR chunk. Okay. Now after that, you can see 4 bytes which represent the CRC value. Now these CRC values, they are computed of the data bytes that are present inside the chunk. Okay. Now this is a structure that is often followed by most of the by all of the PNGs. Now you guys can see something interesting here. You can see the gamma chunk, right? So gamma is essentially nothing but an ancillary chunk. You don't need an ancillary chunk for a PNG. Ancillary chunks are basically nothing but these are the chunks that your image does not necessarily need to exist. Your PNG can have them or it may not have them. It can store data that is not relevant or irrelevant to the PNG. Now, again, as you can see, you again have even for ancillary chunks, the structure remains the same. You have the chunk name, 4 bytes before that represent the chunk length, and the bytes after the chunk name represent the data of the chunk, and the 4 bytes at the very end represent the CRC value. Now, as I was mentioning, CRC value are often calculated from the data that is present inside the chunk. So, what a good method. So, one way in which people corrupt the file is by messing up the data that is present inside the chunk data segment. Now, the more important aspect of a PNG, or I would say the most important chunk in a PNG, is the IDAT chunk. As the name suggests, IDAT, image data. That's what IDAT literally stands for. Now, So, so as I was mentioning, and a PNG can have multiple IDAT chunks. It's not necessary that a PNG can only ever have one IDAT. A PNG can have more than one IDAT. And as you can see, all the bytes that you see here, these are basically your compressed RGB values. So what are RGB values? So every pixel that you have in a PNG, right, comprises of RGB values. Now, when you think of RGB values, imagine you have the white color. The white color is consisted of seven colors. Now each pixel that you have is something very similar. Each pixel is comprised of three main color channels. They are mainly red, green, and blue. So different, yeah. So when you have, as I was mentioning, your pixel values, they have RGB values. Now every pixel that you have in your PNG is different combinations of these RGB values. Now these combinations are what gives rise to different uh, colors. Now now I'll show you guys what RGB colors actually are. As you guys can see, as I manipulate the values over here, you can see the overall uh, overall color frame change over here. That is what the manipulation of RGB does the overall PNG structure. Now, this is what is displayed across the entire PNG structure. You have multiple pixels, and each pixel is a combination of different RGB value. Each each of red, green, and blue values, they range from 0 to 255. You can you can have any value for each RGB from 0 to 255. Any doubts? Do you guys have any doubts, or is it clear? Okay. If not, I'll again resume with my session. Okay. 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 So I was talking about the IDAT chunk. IDAT chunk is what has your image data. So all your pixels, they are compressed using a method called the zlib compression, which you don't have to worry about. I'll just tell you what it does. It just compresses all your RGB values and makes it, you can't store raw data as it is. You have to compress it somehow, fix it inside a file structure. That is why you do zlib compression. Now, all PNGs, they end with an end chunk, which basically shows the end of image. Now, as you can see, the end chunk has 0 bytes as its data. And you can also see that it also has a CRC value. Now, the good thing about end chunks is you don't have to worry much about this. If people append extra things after the end chunk also, the PNG would still open, and it's totally fine to do that. Now, the uh, the CRC value of the ion chunk always remains constant throughout the PNGs. As you can see, I have boat.png here. If I open any other PNG also, it would again display the same RG, it would again display the same CRC value for the ion chunk. See, as you can see, the ion chunk has the length data length as 0. It has the same CRC here again. That is AE4260 and 82. Okay. Now, I'll talk about the different means by which you can corrupt the PNG. So usually what people they do is they manage to mess up the PNG header and all. I'll show how it works. So you have the chal1.png here, right? So if you go here and if you mess up the uh, first byte of the magic header, you can see that the PNG will not open anymore. See, see, it says the image cannot be opened or the format is not supported. Now, a lot of the times people just remove these, truncate these first 8 bytes and call it a challenge. But then the level of corrupting a PNG can vary from here to a lot more extent. I'll fix this for now. And the second method by which they can do is they can corrupt the chunk length. So if I corrupt the chunk length, for example, I make this 0R. That also corrupts the image. Now, when you talk about other ways of uh, corrupting the PNG structure, what really happens is you can also mess around the uh, CRC values. Now, a lot of the times, what Windows systems do is not Windows, I mean applications like image viewers and all. They actually have a preset CRC calculator value which actually calculates you the CRC value and then lets you open the PNG even if the data inside that is actually not correct. So in my device, if I do in the ISDR chunk itself, if I mess up the data, let me make it 89 or 98. You can we would still be able to see the PNG again. That is mainly because what really happens is, as I said, image viewers and all, they let you they calculate the CRC value and they let you uh, view it even without any issues. And but then this is only valid in case of Windows systems. That is not supported in case of Linux-based systems. In Linux-based systems, if you mess up any of the data bytes of any of the chunks, what really happens is it messes up the entire file structure, and you'll have to manually fix the bytes. Okay. Any doubts? Does anyone have any doubts? Karthik, I mean, I think you're finding the session a bit too interesting. Thank you for that. I really appreciate the comments. Does anyone have any doubts? Wait for 1 minute. Okay. So in the meantime, I would like to talk about InCTF. So InCTF is a competition that is conducted by Amrita Vishwa Vidyapeetham and initiated by BIOS. So we keep this contest every year in order to make people or make students more interested into contests like CTFs. And this year also we are conducting it again. And for those who are willing to participate, go to the they can go to the NCTF website, NCTFJ website, and they can start registering now. The registration dates are only till December 8th, and the registration is, by the way, completely free. Anyone can, no money is involved. Anyone can take part in this, and it's not for college students or anyone. It's mainly for school students from for first grade to 12th grade. And regarding more info for NCDFJ, the quals will be taking place on 13th of December. Yeah, yeah, it will be 13 on it will be taking place on 13th December, and it will be online. And for those who make it past the qualifiers round, they can participate in the on-site finals in Amrita, which will take place in the second week of January. See you on the scoreboard, everyone. Thank you. Okay. So that was regarding PNG file structures. Now, I would go ahead more to talk about the JPEG file structures. Now, in case of JPEG file structures, what really happens is that the way they both store data differs hugely in case of both JPEG and in case of both JPEG and PNG. The way JPEG stores data is way more complex than how PNG stores data. Okay, so differences between PNG and JPEG, those can be inferred from this image that I'll be showing you now. As you as you guys can see, as you guys can see, this is how JPEG usually stores data. Now, if you look at it, if you look at it, if you look at it, you can clearly see that the way it stores data is very different from how PNG does it, and uh, the overall complexity of how JPEG store data is way more than how PNGs do. Now, if you look at the first two bytes of the JPEG file structure, these are called the start of image. Okay. Now, a PNG usually consists of the start of image and end of image, and there will be quantization tables, which are also called DFT, and there will be start of frames, Huffman tables, and start of scan and start of frame also. I'll be explaining about these in briefly. So you can see all JPEGs that you have one thing in common, and that is, as you can see, you have the FFDA, which is like the start of image of a JPEG. It is the start of image that lets your device know that whatever you're using is a JPEG. Okay. Now, after that, you can also see FFE0. So FFE0, these are nothing but application segments in a JPEG. So what application segments are actually in JPEGs are, they basically store metadata related stuff. What is metadata? I have whenever you type to commands like exif tool, suppose I so whenever you use tools like exif tool and all, you can see that dimensions, the color methods it uses, the bit depth and all of that in case of PNGs and also for JPEGs. Now the application segment in a JPEG basically stores all the metadata related content in uh, the application segment. Now each JPEG, just like a PNG, also ends with uh, an end of file, and that is called the FFD9. The FFD9 segment basically represents the end of file in case of a JPEG. Now, the way how these two store data differ hugely. In case of PNGs, you have pixels, and inside the pixels, you have RGB values. Now, in case of JPEGs, what really happens is you compress all the RGB into constraints called as Y, CB, and CR. Now, these are nothing but planes. Now, these planes, they are just compressed values of your RGB contents. Now, what they and the way they are represented and the way they are represented across the PNG structure differ differs a lot. Now, what Y is? Y stands for luminous. Luminous basically means brightness, how bright the image is. So, whenever we say that JPEG is always intended to have more luminous value than the CB and CR constraints, because the image should look visually appealing to human eyes, and that is why you have the luminous value set up so high. Now, the way that these values are stored, right? These are called DCT tables. Now you have DCT coefficients in case of uh, in case of JPEGs. So DCT basically stands for discrete cosine transformations. You basically all your RGB values, right? They're converted to YCB and CR, and each of these YCB CR planes, they have the DCT coefficients. Now these coefficients, they are computed using complex mathematical equations, and you guys don't have to worry about that. Now, in order to look at where the quantization table falls, we can just again go to your hex editor. You can just look for FFD8, which basically is the okay, as you can see, and it is also not necessary that what to say that a PNG can have quantization tables, because these are just the segments that compress your data. The DQT is what compresses, the DCT is what stores what has the DCT values. Now you also have another type of table called the Huffman tables. So what Huffman tables do is they're basically nothing but used to perform encoding on the transformed YCB and CR values, and you use DST tables to do that. Now, then you have something called as frame markers. Each JPEG has frame markers. Now, these frame markers that you can see, 1 second. So you have starter frames in your JPEG, store all the which basically store all the DCT coefficients. Now, it is in the starter frame that uh, basically defines what all quantization table is being used by that specific frame, what all quantization table is being used by that specific frame, and what all Huffman tables are being used by that frame. Now, each JPEG also has what you call as uh, start of scan. So it is these segments that basically store. It is these segments that basically store the DCT coefficients. All the data that you have, all the compressed data that you have, are usually stored in the start of scan segment of the JPEG. I hope the file structure is clear to everyone. Uh, any doubts? Does anyone have any doubts? I'll wait for 1 minute. Okay. So as there are no more doubts, I'll get along with the challenge solving session. Now, yes. So I'll be mainly solving one challenge from a PNG and one from JPG. So you have this PNG over here. Let me just use my terminal. Now, Okay, so this challenge is about using a tool called ZStack. So what ZStack does is, how many of you are familiar with the term called LSB encoding? Hello, anyone familiar? A yes or a no would do. Okay, so I'll continue with my explanation. So, what one of the major prominent ways in which flags are usually hidden in PNG file structures is by encoding the flag bits into the into the LSBs of the RGB values. Now, what really happens is, how many of you know what LSB is? Okay. For those who don't know, LSB is like you have your binary representation, right? So when you have the binary representation, you can see that it usually grows, the value grows from the right to the left. So what really happens is, to the right, you tend to have smaller values. So as those values have smaller values, people can usually encode flag into those bytes, into those bits. Okay. And that's the whole idea behind LSB encoding. You replace what is there in the LSB with the flag bits and you encode it that way. So CSTEC is one such tool which is used to identify LSB encoding in PNG images. So you have the PNG here. The PNG is called chal1.png. I'll run the tool ZSTEC on the PNG. Here you go. You have the flag, which basically. So, do you guys see this B1, BGR, LSB, XY? This XY basically represents the, what to say, pixel notation. Okay. And then you have the blue, green, red, you have the LSB, and then this is what has been encoded into the LSBs of the RGB. You have the flag there. Now, for the second challenge, I'll be performing it on a JPEG, as JPEGs usually have a more complex file structure. So now you have the JPEG over here. So one of the common ways by which you know JPEGs the flags are encoded in the JPEGs is again LSB encoding. But then LSB encoding in case of JPEGs is slightly different. You have the tool called JSTEC. Okay, you have to use the tool called JSTEC in order to detect LSB encoding in case of JPEGs. So I'll be using the tool JSTEC. Uh, There you go. The LSB does not have any hidden data inside it. So what does that mean? What all other tools can I use on the JPEG? So so okay. Now by I mean these are the few things you should always try before even trying any other tools. Sometimes the flags are directly encoded in the other in exif tool. Okay, so as you can see, there is nothing in exif tool as well. Now what do I do? Hmm, interesting. So there is something called as steg hide, which is used to detect whether there are any hidden files or content inside the file, inside the JPEG. Now, what I will do here is that I will use the tool called steg hide. Steg hide. As you can see, it prompts me for password. Okay, I really don't know the password, so I don't know what I'm going to do. So, what we can do is there is a word list called as rock you. So what it does, what it has is basically has it's a word list that has all the popularly used random passwords that you can use in order to brute any. in any process, especially in case of tools like StegHide. So what brute force basically means is that you try different possibilities at a specific instance and check what really works. Now, in this case, we don't know the password. So there is a tool called StegSeek, which is used to brute StegHide passwords. Now, my peer Lasya showed the use of StegSeek yesterday. But then again, just for clarity, I'll show it again once more. So s- you put StegSeek first, then whatever your JPEG name is, then you'll put the word list that you're using. So my raw queue is in my downloads directory. So what I'll do is I'll go back and then I'll use raw queue.txt. Yeah. So as you can see, we found the passphrase and that is this. And we also got a file name called flag.txt. Now, to get the flag, I'll just copy the passphrase. I'll again do steg hide and then I'll enter the passphrase there. Yes, now it has written the flag to the flag.txt file. Now you have the flag over here. Yeah, that's it. Okay. Does anyone have any doubts from whatever I've done till now? If you want, you can put it in the chat if you guys have any doubts. Okay, so people often wonder why studying file structures and all is necessary. So usually what happens is that file structures, they can act as stealth factors to a lot of different uh, malicious actors such as malwares. So I'll talk about what malware. How many of you know about malwares? Okay. It's not a very popular term I see here. So basically, it's like malicious software, something that can mess up with with your system. And there have been instances in the past where attacks have taken place, in which they have used the application segments of the JPEG file in order to provide stealth. Now, what really happens is your Gmails and all, right? Whenever you transfer files from Gmails, your Gmail and all detects whether the file has some malicious content or not. And if it does, it won't let you parse it. Now, what happened in case of a few malwares was that they use the application segment. They use the application segment and they used it as a stealth factor for for the malware. And it becomes necessary to learn file structures because only when you go through the file structures you are able to understand what really is there and what should be there, what really should not be there. Shivania D4X, hello, nice to meet you. Yeah, so that is one of the major reasons why one should take up interest in learning file structures. And yeah, that's it for the session. Thank you. Does anyone have any doubts? Does anyone have any doubts? I'll wait for another 2 minutes. Does anyone have any doubts? Or else I'll wind it up. Does anyone have any doubts? Okay, thank you for your patience. Bye bye, everyone. Hello, Changoda. Do you have any doubts? If you guys have any more doubts, you can join the InCTF Discord channel. We'll be ending the stream now. Bye.